The natural world is full of extraordinary creatures, each with its own unique adaptations and survival strategies. Among these fascinating creatures, the velvet ant stands out as a true marvel of evolution, a tiny insect that captivates the eye with its dazzling beauty, while simultaneously striking fear into the hearts of those who dare to get too close. Often mistaken for an ant due to its lack of wings and fuzzy exterior, the velvet ant is actually a type of wasp, and a particularly formidable one at that. Its vibrant colors, ranging from fiery reds and oranges to deep blacks and iridescent blues, are not just for show. They serve as a stark warning to any would-be predators, signaling the presence of a potent sting that can deliver excruciating pain. Join us as we delve into the captivating world of the velvet ant, exploring its unique biology, its fascinating behaviors, and the delicate balance between beauty and danger that makes it such a compelling subject of study. The name velvet ant is a misnomer, a testament to the deceptive nature of this intriguing insect. While its fuzzy body and ant-like appearance might fool the casual observer, the velvet ant is, in fact, a type of wasp belonging to the family Mutilidae. This intriguing family comprises over 3,000 species, all of which share a common characteristic. The females are wingless, while the males sport fully developed wings, creating a striking visual disparity between the sexes. Unlike their airborne male counterparts, females spend the majority of their lives on the ground, scurrying through leaf litter, burrowing into the soil, and infiltrating the nests of other insects. These insects are solitary creatures, lacking the complex social structures and hierarchical colonies of true ants. The velvet ant is a testament to the artistry of nature. Its exoskeleton adorned with a dazzling array of colors and patterns that rival the beauty of the most precious gemstones. From the fiery reds and oranges of the eastern velvet ant to the iridescent blues and greens of certain tropical species, these insects are a sight to behold. But the velvet ant's beauty is more than just skin deep. Its vibrant colors serve as a warning signal to potential predators, advertising the presence of a potent sting capable of delivering excruciating pain. This strategy, known as aposematism, is common in the animal kingdom, with many brightly colored species possessing chemical defenses that make them unpalatable or even dangerous to consume. The velvet ant, despite its misleading name, is a fascinating example of nature's tendency to blur the lines between different insect families. While its fuzzy appearance and ground-dwelling habits might lead one to believe it's a type of ant, closer examination reveals its true identity as a wasp, specifically a member of the family Mutilidae. This family, comprising over 3,000 species worldwide, is characterized by the wingless females, which bear a striking resemblance to ants, and the winged males, which often display a more typical wasp-like appearance. Like other wasps, they possess a narrow waist known as a petiole, connecting the thorax and abdomen, a feature not found in ants. Additionally, velvet ants possess a stinger connected to a venom sac, a formidable weapon used for both defense and subduing prey. The Mutilidae family, to which the velvet ant belongs, is a fascinating group of insects, united by their shared tendency towards mimicry and their often painful stings. Despite their diversity, these insects share a common thread. The females are always wingless, resembling ants in their morphology and behavior, while the males possess wings and often exhibit a more wasp-like appearance. The wingless females, often brightly colored and adorned with dense hair-like structures called setae, are the ones most frequently encountered by humans, their ant-like appearance often leading to misidentification. The males, on the other hand, are typically less conspicuous, their winged bodies allowing them to fly in search of mates and nectar. This deceptive strategy, honed over millennia of evolution, highlights the velvet ant's remarkable ability to exploit the defenses of other species to its advantage. The female velvet ant, with her wingless body and ant-like appearance, is a master of subterfuge, a creature perfectly adapted for a life spent navigating the subterranean world. Unburdened by the need for flight, she has evolved a suite of adaptations that allow her to thrive in environments often inaccessible to her winged male counterparts and other aerial predators. Her robust legs, tipped with tiny claws, provide exceptional traction, allowing her to traverse loose soil, climb over obstacles, and burrow into the ground with ease. Her exoskeleton, tougher and more rigid than that of many other insects, offers protection from the physical stresses of her subterranean lifestyle. To navigate this perilous environment, she relies on a combination of stealth, agility, and, of course, her formidable sting. The velvet ant's remarkable sexual dimorphism, the stark contrast in appearance between males and females, is a testament to the power of natural selection to shape different life history strategies within a single species. The male velvet ant, with his delicate wings and slender body, is a creature of the air, his life a fleeting quest to find a mate and pass on his genes. His wings, often translucent and adorned with delicate veins, carry him swiftly through the air, allowing him to cover vast distances in search of receptive females. The female, on the other hand, is earthbound, her life tethered to the ground by her lack of wings and her parasitic lifestyle. Her body, more robust and compact than that of the male, is built for strength and resilience, allowing her to withstand the rigors of a life spent navigating the subterranean world. Imagine walking through a sun-drenched meadow, your eyes scanning the ground for signs of life. Suddenly, a flash of color catches your eye. It's a velvet ant, its exoskeleton shimmering like a tiny jewel against the backdrop of brown earth and green foliage. The velvet ant's coloration is nothing short of breathtaking. Their exoskeletons, covered in a fine layer of velvety hairs, can erupt in a kaleidoscope of hues, from the fiery reds and oranges of the eastern velvet ant to the deep velvety blacks and iridescent blues of certain tropical species. In the animal kingdom, beauty is often more than just skin deep. It can be a weapon, a shield, a way of communicating vital information without uttering a sound. The velvet ant, with its dazzling array of colors, is a master of this silent language. Its vibrant hues a clear warning to any would-be predator. Approach at your own risk. This strategy, known as aposematism, is a common tactic in the natural world. The velvet ant's coloration is a prime example of aposematism in action. The velvet ant family, comprising over 3,000 known species, is a testament to the diversity of life on Earth. These fascinating insects, found on every continent except Antarctica, exhibit an astonishing array of colors and patterns, each species sporting its own unique aesthetic. From the fiery reds and oranges of the eastern velvet ant to the midnight blacks and iridescent blues of certain tropical species, the velvet ant world is a kaleidoscope of colors. In North America, the eastern velvet ant, Dacimutilla occidentalis, with its striking red and black coloration, is a common sight. In the southwestern United States and Mexico, the velvet ant diversity explodes, with species like the brilliant orange and black Dacimutilla aureola and the iridescent blue and black Dacimutilla klugii, adding to the visual tapestry of the desert landscape. The velvet ant's dazzling colors are more than just a feast for the eyes. They serve a crucial role in the insect's survival, acting as a shield against predators and a means of blending into its surroundings. These intricate patterns, often mimicking the warning coloration of other dangerous insects, are a testament to the power of evolution. In some cases, the velvet ant's coloration serves as a form of mimicry, allowing it to capitalize on the fearsome reputation of other venomous creatures. For example, some species of velvet ant bear a striking resemblance to wasps, with their bright yellow and black bands serving as a visual deterrent to potential predators. In other instances, the velvet ant's coloration helps it blend seamlessly into its environment, providing a form of camouflage that makes it difficult for predators to detect. Section 1. The Cowkiller Legend and Reality. The velvet ant, despite its diminutive size and alluring beauty, harbors a secret weapon that has earned it a fearsome reputation, a sting so notoriously painful that it has been dubbed the Cowkiller. This moniker, passed down through generations of folklore, speaks volumes about the intensity of the velvet ant's sting, painting a vivid picture of an insect whose venom is powerful enough to bring down even the largest of mammals. While the notion of a velvet ant felling a cow with a single sting is undoubtedly an exaggeration, it underscores the very real and excruciating pain these insects can inflict. The legend of the cowkiller likely stems from the observation that cattle, along with other livestock, often react with extreme distress when stung by velvet ants. Their panicked movements and vocalizations, a testament to the intense pain they experience, likely fueled the belief that the venom was potent enough to be lethal to large animals. In reality, while incredibly painful, the velvet ant's sting is not powerful enough to kill a cow or any other large mammal. The venom, while containing a cocktail of potent neurotoxins and enzymes, is primarily designed to paralyze prey and deter predators, not to deliver a fatal blow. The cowkiller legend, therefore, serves as a cautionary tale, a reminder that even the smallest of creatures can possess defenses capable of inflicting significant pain and discomfort. Section 2. Anatomy of a sting. A closer look at the weaponry. The velvet ant's sting, the source of its fearsome reputation, is a marvel of evolutionary engineering, a finely honed weapon that reflects millions of years of adaptation for survival in a world teeming with threats. This formidable weapon, concealed within the female's abdomen, is not merely a sharp point used to inject venom. It's a complex structure that combines mechanical strength, precision and chemical warfare to deliver a painful and memorable lesson to any would-be attacker. The stinger itself is a modified ovipositor, a tube-like structure originally designed for egg-laying that has been repurposed for defense in female velvet ants. Composed of a tough, chitinous material, the stinger is surprisingly long and robust, capable of piercing through the tough exoskeletons of other insects and even the skin of larger animals. Unlike the barbed stinger of a honeybee, which detaches upon use, the velvet ant stinger is smooth and retractable, allowing for multiple stings in rapid succession. At the base of the stinger lies the venom sac, a reservoir containing a potent cocktail of toxins and enzymes that pack a powerful punch. This venom, delivered through a tiny channel running the length of the stinger, is a complex mixture of chemicals, each component playing a specific role in subduing prey or deterring predators. Among these chemicals are neurotoxins that disrupt nerve impulses, causing paralysis, and enzymes that break down tissues, leading to pain, inflammation, and localized swelling. A pain unlike any other, the venom's impact. The sting of a velvet ant is an experience that few forget, a searing, agonizing pain that has been compared to being branded with a hot iron or having a nail hammered into one's flesh. This excruciating sensation, far from being a mere annoyance, is a testament to the potency of the velvet ant's venom, a cocktail of chemicals designed to inflict maximum pain and deter even the most determined predator. The initial sting is often described as a sharp, piercing pain, like a jolt of electricity shooting through the affected area. This initial shock is quickly followed by a wave of intense, burning pain that radiates outwards from the sting site, engulfing the surrounding tissues in a fiery inferno of agony. The pain, far from being fleeting, can persist for hours, even days, a relentless reminder of the velvet ant's formidable defenses. The intensity and duration of the pain are due in part to the complex composition of the venom, which contains a mixture of neurotoxins and enzymes that work in concert to disrupt nerve function and trigger inflammatory responses. The neurotoxins, targeting the nervous system, cause intense pain by interfering with the transmission of pain signals to the brain. Meanwhile, the enzymes, breaking down tissues and cell membranes, trigger the release of inflammatory chemicals that further amplify the pain response, leading to redness, swelling, and a throbbing sensation that can be excruciating. To sting or not to sting defense mechanisms and strategies? The velvet ant, despite its formidable sting, is not an aggressive insect. In fact, it prefers to avoid confrontation whenever possible, relying on a combination of passive and active defense mechanisms to deter predators and navigate its often perilous environment. The sting, while a potent weapon, is often a last resort, employed only when other defense strategies have failed to deter a persistent threat. One of the velvet ant's most effective defense mechanisms is its aposematic coloration. Its vibrant hues a clear warning signal to potential predators that it is not to be trifled with. These bright colors, often mimicking the warning coloration of other venomous insects, serve as a visual deterrent, reminding predators of the painful consequences of attacking such a well-defended insect. In addition to its visual warnings, the velvet ant employs a variety of auditory and behavioral defenses to ward off attackers. When threatened, it can produce a high-pitched squeaking sound by rubbing together specialized structures on its abdomen, a shrill alarm that can startle predators and give them pause. This auditory defense, often accompanied by a display of aggressive posturing, such as raising the abdomen and waving its legs menacingly, serves as a final warning before the velvet ant unleashes its painful sting. However, the velvet ant's primary defense mechanism is arguably its ability to avoid confrontation altogether. Its solitary nature, its preference for camouflage coloration, and its habit of remaining hidden during the hottest parts of the day all contribute to its ability to evade predators and live a relatively peaceful life. It's a testament to the velvet ant's evolutionary success that it has managed to thrive not by being the biggest or strongest insect in its environment, but by being smart, evasive, and, when necessary, armed, with a sting that leaves a lasting impression. Silent invaders, the velvet ant's clandestine operations. The velvet ant, with its flamboyant colors and reputation for inflicting pain, might seem like a creature that lives life on its own terms, a bold and fearless inhabitant of the undergrowth. However, beneath this outward appearance of invincibility lies a creature that employs a surprisingly clandestine strategy for survival: parasitism. The female velvet ant, unable to provide for her offspring directly, has evolved a remarkable adaptation. She outsources the task of raising her young to unsuspecting hosts, turning the nests of other insects into nurseries for her own progeny. This parasitic strategy, while seemingly ruthless, is a testament to the velvet ant's evolutionary success. It allows them to bypass the energy-intensive tasks of nest building and food gathering, freeing them to focus on reproduction and ensuring the continuation of their lineage. The female velvet ant, rather than nurturing her young directly, becomes a master of infiltration, a silent invader that seeks out the nests of other ground-nesting insects, particularly bees and wasps, to deposit her eggs. Her targets are not chosen randomly. The female velvet ant displays a keen sense of timing and a remarkable ability to detect the subtle cues that betray the presence of a suitable host nest. She relies on her keen sense of smell, her antennae twitching as she detects the faintest traces of pheromones, chemical signals released by her unsuspecting victims that betray the location of their hidden burrows. Once a suitable nest is located, the real work begins. The female velvet ant, her body surprisingly strong and agile, digs into the soil, her powerful legs propelling her through the earth as she navigates the labyrinthine tunnels of her host nest. It's a perilous journey, fraught with the risk of encountering defensive parents and the ever-present danger of getting lost or trapped underground. Section 2. Targeting the vulnerable, a preference for ground-nesting bees and wasps. The velvet ant's choice of host is not random. It reflects a finely tuned evolutionary strategy that maximizes their chances of reproductive success. While they have been known to parasitize a variety of ground-nesting insects, their preference lies with the larvae and pupae of solitary bees and wasps, creatures whose nesting habits and life cycles make them particularly vulnerable to the velvet ant's stealthy invasion. Solitary bees and wasps, unlike their social counterparts, do not live in large colonies with dedicated guards and a collective defense system. Instead, they lead solitary lives, each female constructing and provisioning her own nest, a series of underground chambers stocked with food for her developing offspring. This solitary lifestyle, while offering a degree of independence, also makes them more susceptible to parasitism. The female velvet ant, with her keen sense of smell and her ability to infiltrate even the most well-concealed nests, exploits this vulnerability. She targets nests that are actively being provisioned, seeking out chambers where unsuspecting bee or wasp larvae are fattening themselves on the stores of pollen and nectar left by their mothers. These plump, immobile larvae, oblivious to the danger lurking in the shadows, are the perfect targets for the velvet ant's parasitic offspring. The velvet ant's preference for bee and wasp larvae is not merely a matter of convenience, it also reflects a shrewd understanding of nutritional requirements. Bee and wasp larvae, provisioned with a rich diet of pollen and nectar, represent a concentrated source of protein and other essential nutrients, providing the ideal sustenance for the developing velvet ant larva. This ensures that the velvet ant's offspring, upon hatching, will have access to a ready-made food source, allowing them to grow and develop without having to compete with siblings or venture out into the dangerous world outside their host's nest. Section 3. A macabre transformation from egg to parasitoid larva. The female velvet ant, having successfully infiltrated the nest of her unsuspecting host, wastes no time in securing the future of her offspring. With surgical precision, she deposits a single egg on the surface of a plump, unsuspecting bee or wasp larva. This egg, tiny and translucent, is barely noticeable to the naked eye, a testament to the velvet ant's mastery of stealth and deception. Within days, the velvet ant egg hatches, revealing a tiny grub-like larva. This larva, blind and legless, is a far cry from the brightly coloured, heavily armoured adult it will one day become. But what it lacks in physical prowess, it more than makes up for in ruthlessness and a single-minded determination to survive. The velvet ant larva, using its sharp mandibles, immediately attaches itself to its host, its tiny mouthparts piercing the soft exoskeleton of the unsuspecting bee or wasp larva. This marks the beginning of a macabre transformation, a parasitic relationship in which the velvet ant larva gradually consumes its host from the inside out. Initially, the velvet ant larva feeds on the hemolymph, the nutrient-rich fluid that circulates throughout the host's body. This allows the velvet ant larva to grow and develop without immediately killing its host, ensuring a steady supply of nourishment as it progresses through its larval stages. However, as the velvet ant larva grows larger and its nutritional demands increase, its feeding becomes more aggressive, its mandibles tearing into the host's vital organs, slowly draining the life from its unfortunate victim. Section 4. The Circle of Life, Velvet Ant Style, Emerging from the Ashes. The velvet ant's parasitic lifestyle, while seemingly gruesome, is a testament to nature's ability to adapt and thrive in even the harshest of environments. The host larva, its body slowly consumed from the inside out, eventually succumbs to the relentless assault of its parasitic passenger. The velvet ant larva, having devoured its host and reached its full size, is now ready for the next stage of its life cycle. Within the confines of its host's now empty pupal casing, the velvet ant larva spins a silken cocoon, a protective barrier that shields it from the outside world as it undergoes a remarkable transformation. This pupal stage, a period of intense metabolic activity, marks the final transition from larva to adult. Inside the cocoon, the velvet ant's body undergoes a complete metamorphosis, its tissues reorganizing, its organs developing, and its exoskeleton hardening into the familiar, brightly colored armor that characterizes the adult insect. Finally, when the transformation is complete, the adult velvet ant emerges from its cocoon, its body soft and pale, its exoskeleton gradually hardening and darkening as it comes into contact with the air. It digs its way out of the underground chamber, leaving behind the empty husk of its host, a testament to the circle of life, velvet ant style. The newly emerged velvet ant, free from its parasitic past, is now ready to face the world on its own terms. The female, her body now adorned with the vibrant colors and formidable sting that characterized her species, will soon embark on the same parasitic journey as her mother, seeking out unsuspecting hosts to continue the cycle of life. The male, his wings carrying him swiftly through the air, will search for a mate, his brief life dedicated to ensuring the continuation of his lineage. The velvet ant's beauty is more than just a pretty facade. It's a suit of armor, a testament to nature's ability to blend aesthetics with functionality. Beneath its velvety exterior lies an exoskeleton of remarkable strength and resilience, a formidable defense against the myriad threats that lurk in its environment. This exoskeleton, composed primarily of chitin, a tough, flexible polysaccharide, acts like a suit of armor, protecting the velvet ant from predators and the rigors of its subterranean lifestyle. The exoskeleton's strength lies not only in its composition but also in its structure. It's made up of numerous interconnected plates or sclerites, which provide both flexibility and rigidity. This allows the velvet ant to move with surprising agility while also being able to withstand crushing forces that would easily pulverize softer-bodied insects. The velvet ant's exoskeleton is particularly thick and durable in the head and thorax regions, which house vital organs and are most vulnerable to attack. This natural armor plating provides added protection against bites, stings, and the crushing jaws of predators. The abdomen, while still well protected, is slightly more flexible, allowing for the expansion and contraction necessary for breathing and egg-laying. This remarkable exoskeleton, a marvel of evolutionary engineering, is a key factor in the velvet ant's survival. It allows them to navigate tight spaces, burrow through soil, and even withstand the occasional trampling by larger animals, all while remaining relatively unscathed. It's a testament to the power of natural selection that even the smallest of creatures can evolve defenses that rival the armor of medieval knights. The velvet ant, while heavily armored, is not one to rely solely on brute force for protection. Its survival hinges on a combination of defensive strategies, chief among them its remarkable agility and unpredictable movements. These insects are masters of evasion, their movements a blur of erratic dashes, sudden stops and lightning-fast changes in direction that leave predators bewildered and off balance. This unpredictable behavior is not merely a matter of speed, it's a calculated strategy designed to exploit the predatory instincts of their attackers. Many predators, particularly those that rely on sight to hunt, are programmed to anticipate the movements of their prey. The velvet ant, by defying these expectations, throws its attackers off guard, making it incredibly difficult for them to predict its next move. Imagine a lizard, its eyes fixed on a velvet ant scurrying across the forest floor. It lunges, its tongue lashing out, only to find itself grasping at empty air as the velvet ant, with a sudden burst of speed, darts to the side, disappearing into the undergrowth before the lizard can react. This ability to outmaneuver predators, coupled with its tough exoskeleton, makes the velvet ant a surprisingly difficult meal to catch. This evasive strategy is particularly effective against larger predators, such as birds and mammals, whose size and momentum make them less agile and more reliant on predictable movements from their prey. The velvet ant, by contrast, is a master of its domain, its small size and nimble movements, allowing it to navigate the undergrowth with a speed and agility that larger predators simply cannot match. The velvet ant, unlike many other insect species, does not rely on the strength of numbers for protection. It's a solitary creature, its life a testament to the adage that sometimes it's better to be alone than in bad company. This solitary lifestyle, while seemingly isolating, offers several survival advantages, allowing the velvet ant to avoid the risks associated with group living while maximizing its chances of reproductive success. Living in groups while offering protection from predators through sheer numbers also comes with increased competition for resources and the potential for disease outbreaks. The velvet ant, by contrast, avoids these pitfalls by leading a solitary existence. It doesn't have to compete with its own kind for food or mates, and its solitary habits make it less likely to be targeted by parasites or diseases that spread rapidly through densely populated colonies. This solitary lifestyle also allows the female velvet ant to focus on her primary mission, reproduction. Unburdened by the demands of colony life, she can devote all her energy to finding suitable hosts for her offspring, ensuring the continuation of her lineage. Her solitary nature, far from being a weakness, is a testament to her adaptability and resilience, a reminder that even in a world dominated by social creatures, there's strength in independence. This is not to say that the velvet ant lives a life devoid of interaction. Males and females do come together briefly for mating, but once this encounter is over, they go their separate ways, each returning to their solitary existence. This brief intersection of their lives is a delicate dance, a balance between the need to reproduce and the instinct to avoid the risks associated with prolonged social contact. Section 4. Sounding the alarm, a tiny siren in a world of giants. The velvet ant's defenses are not limited to its physical attributes and evasive maneuvers. This tiny insect also possesses a surprising acoustic weapon, a high-pitched squeak that belies its diminutive size. This sound, produced by rubbing specialized structures on its abdomen together, serves as an auditory warning signal, a shrill alarm that can startle predators and give them pause. This squeaking sound, while barely audible to human ears, is easily detected by the velvet ant's natural predators, many of which rely on sound as well as sight to locate prey. The sudden, unexpected noise can startle a predator, giving the velvet ant precious seconds to make its escape. Imagine a bird, its sharp eyes scanning the ground for a tasty morsel, suddenly hearing a high-pitched squeak coming from beneath a pile of leaves. The bird, startled by the unexpected noise, hesitates for a moment, its instincts telling it that something is amiss. This brief pause is all the velvet ant needs to make its getaway, disappearing into the undergrowth before the bird can recover from its surprise. This auditory defense mechanism, while seemingly simple, is remarkably effective. It allows the velvet ant to exploit its predator's instinctive fear of the unknown, turning a potential weakness, its small size, into a strategic advantage. It's a testament to the power of evolution that even the subtlest of adaptations can play a crucial role in an animal's survival. Section 1. Global citizens, velvet ant habitats around the world. Velvet ants, these dazzling jewels of the insect world, are far from being confined to a single corner of the globe. They are true global citizens. Their range spanning continents and encompassing a wide array of habitats. From the sun-drenched deserts of the American Southwest to the lush rainforests of Southeast Asia, these adaptable insects have carved out a niche for themselves in some of the world's most diverse ecosystems. North and South America boast the greatest diversity of velvet ant species, with over 3,000 species identified across the two continents. Here they can be found in a variety of habitats, from the arid deserts and scrublands of the southwestern United States and Mexico to the temperate forests and grasslands of the eastern United States and Canada. Venture further afield and you'll find velvet ants thriving in equally diverse environments. In Africa, they inhabit savannas, grasslands, and even the fringes of the Sahara Desert. In Asia, they can be found in rainforests, mountain meadows, and even urban gardens. Their adaptability is a testament to their evolutionary success, a reminder that life, even in its smallest forms, finds a way to thrive in a multitude of environments. The velvet ant's success in colonizing such a wide range of habitats is due in part to its remarkable adaptability. These insects have evolved a suite of physiological and behavioral adaptations that allow them to withstand extremes of temperature, moisture, and food availability. Their tough exoskeletons provide protection from the elements, while their ability to burrow underground offers refuge from the scorching sun and the chilling winds of winter. Section 2. Adapting to extremes, thriving in harsh environments. The velvet ant's global distribution is a testament to its remarkable ability to adapt to a wide range of environmental conditions. From the scorching deserts of the American Southwest to the humid rainforests of the Amazon basin, these resilient insects have carved out a niche for themselves in some of the world's most challenging habitats. Their success in these extreme environments is a testament to their evolutionary ingenuity, a story of survival written in the language of adaptation. In arid regions where water is scarce and temperatures can soar to life-threatening levels, velvet ants have evolved a suite of adaptations to conserve moisture and regulate their body temperature. Their tough exoskeletons act as a barrier against water loss, while their ability to burrow underground provides access to cooler, more humid microclimates. Some species have even evolved specialized hairs on their bodies that reflect sunlight, reducing heat absorption and helping them stay cool in the scorching desert sun. At the other end of the spectrum, velvet ants found in humid rainforests face a different set of challenges. Here, the constant moisture and abundance of decomposing organic matter create ideal conditions for fungal growth, a potential threat to insects with exposed exoskeletons. To combat this, many rainforest-dwelling velvet ants have evolved symbiotic relationships with bacteria that produce antifungal compounds, protecting them from infection. These are just a few examples of the velvet ant's remarkable adaptability. From the deserts to the rainforests, these insects have found ways to thrive in environments that would challenge the limits of many other creatures. Their story is a testament to the power of natural selection, a reminder that life, even in its smallest forms, finds a way to adapt and persist in the face of adversity. The velvet ant, with its striking appearance and reputation for inflicting pain, has captured the imaginations of people across cultures and continents. It's an insect shrouded in folklore, its life cycle and behaviors a source of both fascination and fear. Let's delve into the world of velvet ant trivia, uncovering some lesser-known facts about these enigmatic creatures. Not all velvet ants are created equal. While all female velvet ants possess stingers, the potency of their venom varies significantly between species. Some species deliver stings that are incredibly painful, earning them the nickname cow killer, while others have stings that are relatively mild, more akin to a bee sting. Male velvet ants are the flying aces. Unlike their wingless female counterparts, male velvet ants possess wings and are often seen flitting about in search of mates. Their aerial acrobatics are a sight to behold, their delicate wings carrying them effortlessly through the air. Velvet ants are masters of disguise. Many species of velvet ant exhibit mimicry, their coloration and patterns resembling those of other more dangerous insects, such as wasps and bees. This clever disguise helps them deter predators who have learned to avoid these stinging insects, the squeak of surprise. When threatened, some species of velvet ant can produce a high-pitched squeaking sound by rubbing specialized structures on their abdomens together. This auditory defense mechanism is thought to startle predators, giving the velvet ant a chance to make its escape. These are just a few of the fascinating facts that make velvet ants such intriguing creatures. The velvet ant, despite its widespread distribution and the attention it has garnered from entomologists and nature enthusiasts alike, still holds many secrets. With over 3,000 known species and countless more yet to be discovered, the world of velvet ants is a vast and largely unexplored frontier, a treasure trove of biodiversity awaiting further exploration. Scientists estimate that the actual number of velvet ant species could be significantly higher than the current estimate, with many species likely residing in remote or unexplored regions. The rainforests of South America, the mountains of Asia, and the deserts of Africa all hold the potential to harbor new and fascinating velvet ant species, each with its own unique adaptations, behaviors, and ecological roles. The discovery of new velvet ant species is not merely an exercise in cataloguing biodiversity, it's an opportunity to gain a deeper understanding of the evolutionary processes that have shaped life on Earth. Each new species is a piece of the puzzle, providing insights into the complex relationships between organisms and their environments, the role of natural selection in shaping adaptations, and the interconnectedness of life on our planet. The velvet ant, with its dazzling beauty, its formidable defenses, and its hidden world of parasitic intrigue, is a reminder that even the smallest and seemingly insignificant creatures can hold the keys to unlocking some of nature's greatest mysteries. As we continue to explore the world around us, we can be sure that the velvet ant, in all its diversity and wonder, will continue to surprise and amaze us. The velvet ant, with its shimmering exoskeleton and captivating colors, stands as a dazzling paradox in the natural world. Its beauty, reminiscent of precious gemstones scattered across the earth, belies a hidden arsenal of defenses, a potent sting that serves as a stark reminder that appearances can be deceiving. This intriguing duality, the juxtaposition of alluring beauty and formidable danger, is a hallmark of the velvet ant's allure, a testament to nature's ability to craft creatures that are both captivating and intimidating. The velvet ant's vibrant hues, far from being merely decorative, serve as a warning signal to potential predators, a visual testament to the painful consequences that await those who dare to challenge its defenses. This strategy, known as aposematism, is a common theme in the animal kingdom, a reminder that in the game of survival, the boldest colors often belong to the most dangerous players. Yet, there's a certain elegance to the velvet ant's defenses, a sense of restraint that underscores its place in the delicate balance of nature. While its sting is undeniably painful, it's rarely fatal, serving primarily as a deterrent rather than a death sentence. This measured response, this understanding of the delicate balance between offense and defense, is a testament to the velvet ant's evolutionary wisdom, a reminder that survival is often about choosing your battles wisely. The velvet ant, despite its diminutive size, offers a powerful lesson in adaptation and survival. Its story, woven into the fabric of diverse ecosystems across the globe, speaks to the tenacity of life, its ability to thrive in the face of adversity and carve out a niche in even the harshest of environments. From the sun-scorched deserts to the humid rainforests, the velvet ant's adaptability is a testament to the power of natural selection, a reminder that even the smallest of creatures can overcome seemingly insurmountable challenges. Its armored exoskeleton, its unpredictable movements, its mastery of camouflage and mimicry, these are all testaments to the velvet ant's evolutionary ingenuity, its ability to turn potential weaknesses into strengths. Its parasitic lifestyle, while seemingly ruthless, is a testament to its resourcefulness, its ability to exploit the vulnerabilities of other species to ensure the continuation of its own lineage. The velvet ant's story is a reminder that size isn't everything in the game of survival. It's a testament to the importance of adaptability, the ability to change and adapt to new challenges, and the power of resilience, the capacity to bounce back from adversity. In a world facing unprecedented environmental change, these lessons are more relevant than ever, reminding us that even in the face of uncertainty, life finds a way. The velvet ant, though often overlooked amidst the grandeur of larger, more charismatic creatures, holds a unique place in the tapestry of life on Earth. Its story, a blend of beauty, danger, and remarkable adaptation, serves as a reminder of the intricate web of life that connects all living things, a testament to the power of evolution to shape creatures of astonishing diversity and resilience. Its legacy extends beyond its ecological role, serving as a source of inspiration for artists, writers, and anyone who marvels at the wonders of the natural world. Its vibrant colors have inspired paintings and textiles. Its unique biology has fueled countless research projects, and its place in folklore and mythology speaks to its enduring hold on the human imagination. The velvet ant's story is a reminder that there's beauty and wonder to be found in even the smallest and seemingly insignificant creatures. It's a call to appreciate the intricate details of the natural world, to marvel at the diversity of life that surrounds us, and to approach the unknown with a sense of curiosity and respect. As we continue to explore the world around us, let the velvet ant serve as a reminder that the greatest discoveries are often found not in the grandest of spectacles, but in the hidden corners of nature, where beauty and danger intertwine to create a tapestry of life that is both awe-inspiring and endlessly fascinating.